Welcome to Microscan's Introduction to Machine Vision, an educational webinar series to help new users better understand the basics of machine vision technology. This is the first installment in our series, and over the next 10 minutes or so, I'm going to talk about what machine vision is and how it's used in factory automation, along with the 4 most common applications of the technology. So, let's get started with a definition of machine vision. Machine vision is defined as the automatic extraction of information from digital images. So, what exactly does that mean? Well, let's look at a very basic breakdown of a typical machine vision process. First, you have a manufacturing production line with a steady flow of objects. Then, you have a camera or optical system trained on the line. Next, you make sure that you have proper lighting of the line so the camera can see the necessary details. The camera captures digital photographs and analyzes the images against a defined set of criteria. That's in an industrial context. There are different types of vision that are used for other purposes, but when we refer to machine vision, we're talking specifically about industrial vision as it's used in a manufacturing environment. Manufacturers use automated machine vision instead of human inspectors because it's faster, more consistent, and works for longer periods of time. Vision technology got its start in the 1950s, but the widespread use of machine vision in industry arose in the 1980s and 90s. This photo, taken from the Wikipedia entry on machine vision, shows a pioneering demonstration at a 1983 trade show of a system by Automatics, which is now part of Microscan. Of course, machine vision has come a long way since then, and is now used for many different valuable processes in manufacturing. Let's talk about some of the most common applications of machine vision. As it has developed, machine vision's applications have grown into 4 basic functions: measurement, counting, location, and decoding. Since its start, machine vision has been widely used for measurement, and by this we mean the automated measurement by a machine. That measurement can then be checked to a specified tolerance. For example, something we've been doing for years with machine vision is measuring the gap in spark plugs. As you may know, this gap needs to be a certain width, or the car won't run as well. Therefore, this gap measurement is an extremely critical spec for the part. We can use a camera and measure the spark plug gap by machine. This eliminates the need for a person to be there to measure and adjust the gap manually. We can automate the process and do it more quickly and accurately. Counting is another typical machine vision application. There are a few different tasks that fall under this category, but basically, counting means to look for a number of parts or a number of features on a part. This allows us to locate missing parts and ensure that products are assembled properly. This example shows an aluminum flange with some holes drilled in it. If you count the number of holes, you'll see that there are exactly 8 of them. Assuming that we wanted 8 holes, we know that the drilling process was done properly. Another counting function is absence-presence. Is it there or not? Here we have an 8-pack of sodas, and you can see that one of the sodas is missing. With machine vision, that packaging can be checked to make sure an incomplete pack doesn't make it to the grocery store shelf. We've slowed the process down so you can see it, but machine vision systems can operate much faster. Location is when machine vision is used to report the position and orientation of a part. This may be done for several reasons. We can locate the position and orientation, and then check that to a specified tolerance. So, in other words, you're looking at the part to make sure that it's at the correct angle, and using that as a reference point to verify proper assembly. You can also use this for alignment to other machine vision tools. Let's take our spark plug example. This is a very powerful feature in machine vision. Your parts may be facing all different directions as they go down your production line, and you can locate a part, straighten the image, and then you can run other machine vision processing tools on it. Additionally, you can find a unique pattern and use that to identify a part. An example you can see here is a can of soup. The vision system has been trained to look for a pattern on the soup. In this case, the portion of the label that says tomato on it. We can use that pattern to verify that we do, in fact, have the right soup going down the line. Decoding refers to the decoding of 1D and 2D symbologies, such as linear barcodes, stacked symbologies as you see here, and 2D symbologies, such as data matrix codes. This also refers to OCR, or optical character recognition, which is text that is simultaneously human and machine readable. Decoding is typically used to record information as historical data. That way you have a record of parts that have gone through a process. You can track the path that a part took through that process and use that data for immediate action, meaning that you can look at the data and sort based on what it says. You can also validate the data for correctness. When you read a marked code on an object, you can verify that the data in the mark is correct, or that the format of the data is correct, or that you have the correct product going down a production line. An obvious question here is, why use machine vision to do this, when dedicated auto ID systems would do the same thing? You might think of machine vision as auto ID or barcode reading plus. The plus is the ability to run other measurements and operations in combination with the reading of barcodes or text. For example, you might want to read a label and also check that it's properly aligned to the product. In other cases, you may need the ability of a machine vision system to tackle tougher applications that require more capability in terms of image pre-processing, or in the case of a PC-based system, sheer speed and processing power. An example of this sort of application is reading the OCR code on a can of vegetables during a high-speed canning process. You may not realize that when vegetables are put into cans, they are usually done so with no labels, and the only indication of what's inside is a text code on the end of it. When the time comes to put the label on the can, a vision system checks the code on the end of the can to make sure that the right vegetable is inside the can and matches the label. So, let's review. Machine vision is the automatic extraction of information from digital images. And we talked about the common manufacturing applications of machine vision, which generally fall under 4 basic functions: measurement, counting, location, and decoding. The visual examples we've shown you here are mostly slowed down so you can see what's happening. In reality, machine vision can operate much faster, processing hundreds, or in some cases, even thousands of pieces per minute. But that's just one of the many reasons manufacturers are using machine vision. Be sure to check out the next installment in our series, Why Use Machine Vision?, where we'll take a look at the benefits of this technology. And for more machine vision resources, including white papers, applications videos, and online tutorials, be sure to visit our website at www.microscan.com. Thanks for watching.